We're going to do independent and dependent. Okay. We're going to do independent and dependent on the front side here. So two events, okay, whether they're independent or dependent, that's what these definitions are. Two events are considered, the first one is going to be independent if one event does not affect the likelihood or the probability of the other. And we'll do some examples here in 1 second. And then two events are going to be considered, bless you, dependent if the probability of one does affect, or somehow the first event does somehow affect the probability of the second event. Okay, so we're just going to get a couple scenarios here and just write I for independent or D for dependent. So this one says I'm going to flip heads on one coin and tails on a different coin. Independent, or does one affect the other? No, so this is independent. Okay, this one says a blue marble is chosen from a bag and set aside, then a green marble is chosen from the same bag. Dependent, because the act of removing that first marble changes the probability of the second step in that experiment there. Okay, this one says you roll a 5 on a, like you roll dice, you roll a 5 on a die and spin a blue on a spinner. They don't affect each other. They're totally separate. One's rolling dice, one's spinning a spinner, so they're not connected. Teacher chooses one student to lead a group and then chooses another student to lead a different group. That's dependent. So if I pick one of you guys to be a group leader, then that removes you from the pool of other people I can pick to be the other group leader. So that would be dependent. Okay, now how do we calculate these probabilities? Okay, probability of two independent, so they don't affect each other, events to happen at the same time or within succession of each other. Says we'll call this the probability of A and B. It is the probability of A multiplied by the probability of B. And this is going to cause you guys maybe to multiply fractions together, which is why I thought you might want your calculator. Okay, so we're going to do some independent events first. Okay, so this says a bag, I might need my calculator for this. Okay, so bag A contains, I'm just going to write this out as I read it. Bag A has 9 red marbles and 3 green marbles, which would be a total of 12 marbles in my bag, right? And then it says bag B, we have 9 black marbles and 6 orange marbles. And so I've got a total 15 marbles. If I'm just adding 9 and 6 together. So there's 15 marbles in bag B. Find the probability of selecting 1 green from bag A and the probability of selecting 1 black from bag B. So this is probability, I already forgot what color it said. Probability of green. And then I would multiply that by the probability of drawing a black marble out of the second bag. So what is the probability I would draw, and you don't have to reduce the fraction or anything, what's the probability I would draw a green one out of the first bag? 3/12, yes. You don't have to reduce it. There's 3 green marbles, there's 12 marbles in the bag. You don't have to reduce it. Okay, what is the probability I would grab a black marble out of the second bag? 9 out of 15. Okay, and I know both of those can be reduced. Don't mess around with it. Just let the calculator do the work for you. So when you multiply fractions, hopefully you guys remember this, you do not need a common denominator. So if you want to use your fraction key, or I'm just going to use parentheses. I'm just going to do 3 divided by, am I on the screen? Yep. Times 9 divided by 15. And then I'm just going to hit my math, enter real quick. If you need it as a fraction, this would be 3 out of 20. If you need it as a decimal, I have that as a decimal on the screen there, 0.15. If you needed it as a percentage, just scoot your decimal over 2 spots, so that would be a 15% chance that that would happen. Okay, I'm going to try just a little different one here real quick. This one says 2 seniors, one from each of 2 government classes, randomly selected to travel to Washington, D.C. Says Wes is in a class that has 18 people and Emma is in a class that has 20 people. Find the probability that both of these 2 people are selected to go on this trip. So we're going to grab one person out of the 18-person class, one person out of the 20-person class. What's the probability it would be these 2 specific people? Like, what would you multiply together here? So if Wes is in the first class that has 18 kids, what's the probability I would pick him? 1 out of 18, right? All right, so Emma's in the second class that has 20 kids. What is, we should probably start using this and drawing out of there and counting those.
I'll give you 5 red ones, 2 blues, 3 greens, and 2 oranges.
I should.
What's the probability I get a red one?
Okay, I can't remember what you just said the numbers were now.
All right, now it's 4 red because I ate one. That's the problem, the numbers are getting messed up.
All right. So we just multiply these guys. And again, you don't need a common denominator. I can't reduce either one of these, but if I could, I wouldn't need to figure this out. We're just going to multiply these together. Use your fraction key if you want to. I'm just using parentheses because I don't have a fraction key. And I'm going to do my math enter real quick. This would be a 1 out of 360 chance that these 2 specific people, and you can see on my calculator screen there, the decimal there is 0.00, let me round that, I'm going to say 0.003, super small. As a percentage, when you do a percentage, you just scooch that 2 decimal places, so this would be 0.3%. So like if these people were trying to go on this trip together, it would be extremely unlikely that they would randomly be selected to go together. Is anybody having a question? Okay, now, dependent events, just slightly different. We're still going to multiply. The probability here of A and B happening is the probability of A times, and this is a little bit longer, the probability of B, and in that case, assuming that A happened. So if you have dependent events, and the 2 things occurring is the probability of B times the probability of B assuming that A happened. Okay, so sort of a kind of a similar type of a problem, but they're dependent here. So it says if you take a marble from the jar, so it says, I should have read that first to you. Okay, I have a jar with 8 purple marbles, 10 yellow marbles, and 12 pink. What is that? 30 marbles total. So I'm just adding that up real quick here. So there's 30 total marbles in the jar. If you take a marble from the jar and you keep it, the act of you keeping it, holding it out, makes it dependent because it changes how many marbles are in the jar, so that affects the probability of the second event. So if you, like if you're delta, if you hold a card or you hold a marble or hold something out, that affects and changes it to be a dependent probability. So you take a marble from the jar and keep it. Your friend then takes a marble from the jar after you. What's the probability you choose purple and your friend chooses yellow? Okay, so if I just walk up to this jar and I pick out a marble, what's the probability I pick purple? 8 out of 30, right? Okay, now, here's what you're assuming. You are assuming that you picked the purple marble out. Okay, so what is the probability then your friend would pick a yellow marble? Yes, ma'am. All right, so there's 1 less marble because you held it out. You didn't draw a yellow marble, so that doesn't change the number of yellow marbles in the jar. So we would just multiply these 2 guys together. So 8 over 10 times, again, you don't have to reduce. You just do it on your calculator. So probability here would be 8 out of 29, which would be about 0.2, I'm just going to go a couple decimal places, 76, or about 27.6% would be your probability, just depending on how they ask. No, fail at life. Oh, okay. Sorry, 8 out of 30. I don't know why I did that. You guys probably have the correct answer, and I totally don't. All right, so, sorry, it should have been 8 out of 87, which is 0.09, or about 9%. So 9% chance that would happen. I should have noticed that when that percentage was so high. Okay, now, what's the probability we both choose a purple marble? So you walking up and choosing a purple marble is identical. What would be the probability if you chose a purple marble, the person after you would choose another purple marble? 7 out of 29, because you're assuming that you held the purple marble out, so now there's only 7 left. And I'm going to try and multiply this correctly. So 8 out of 30 times 7 out of 29. And you guys can see it's like a super tiny number. I'm going to change that to a fraction just real quick. So if you need to do a fraction, this is 28 out of 435. If you need to do a decimal, depending on how many places we want to round to, I'm just going to go 3. So 0.064, or about 6.4%. Is anybody having a question? I marked on here what they're going to ask you in the questions, just so it'll be a little bit easier to see because they're kind of tiny, little different letters here. So it says you spin the wheel pictured for a game show twice. Okay, the probability your first spin is worth more than 500. So I literally just around here, if you guys look at this, wherever it says A, that dollar amount is over $500. So that's what those all are. You guys have a question? Okay, so 1, 2, 3, 4, 5, 6, 7, 8. All right, so more than $500. There are 8 different spaces on that wheel that are more than $500. Forgive, I'm off the screen a little bit here. Okay, now, the second spin, they want to know if you'll land on the bankrupt. So I just put a little B for event B, if you will, on the bankrupt. So there's 2 bankrupt spaces on the wheel. Now, it doesn't say like we're going to remove anything from the wheel or anything like this. So this 2 separate spins, these should be independent events. One is not going to affect the other. We're not removing something. We're not, pulling the trip off of here or whatever. So it's just going to be what it is here. So the probability your first spin is worth more than 500. And just so we didn't have to count them, there's 24 spaces on this wheel. So 8 out of 24 would be the probability I get more than 500. And the second spin, get a bankrupt, would be 2 out of the same 24 spaces. That bottom number is going to stay the same if you're working with independent events. And so I'm going to do 8 over 24, multiply that by 2 over 24. And again, just depending on how they ask you to write your answer. This would be 1 out of 36 if I was doing a fraction. I'm going to lay it down so you can see it. So it's 0.0, let's say 0.028, or for a couple decimal places out, just depending on what you're asked. So it'd be about 2.8% chance that would happen. Excuse me. All right, now, I don't know how well you guys know stuff about cards, so this might take us a second to figure these out if you don't know them very well. So this says you randomly select 2 cards from a standard 52 card deck. What's the probability the first card is not a face card? So a face card is like a king, queen, or jack. So not a face card would be like ace 1, 2, or ace 2, 3, 4, 5, 6, 7, 8, 9. And then the second card is a face card. Okay, 2 situations. If you replace the first card, then that automatically makes that an independent event, because if you take a card out but you put it back, you make the probability exactly the same. If you hold the card out, that changes the number that you have to pick from, so that second scenario would be a dependent situation. I just want to see if you guys know anything about cards here. So, how many cards in the deck are not a face card? Jackie? You're so close. It's 40. It's 40. 40 out of 52. So it'd be the aces, the 2s, the 3s on up. So there's 40 of them. And then if I put it back, I still have 52 cards. You guys know how many face cards are in a deck? There should be 12. There's 4 kings, 4 queens, 4 jacks, 1 for each suit, so this would be 12. And then I would just go ahead and multiply those together. Remember, you don't have to reduce. You can if you want to, but you don't have to. All right. This is 30 out of 169 as a fraction. As a decimal, this would be about let's say 178, just depending on how the question might ask you to write your answer. Probability has to be between 0 and 1, so we can write it as a fraction or a decimal. Now, if I don't replace the first card, okay, so it would still be 40 out of 52. So I'm going to assume that I drew like a 3 or whatever. I did not draw a face card. What would the second fraction be if I hold out the card that I drew? What would you put on the top? It would just change the bottom to 51. You're still assuming all the face cards are there. So you'd have 4 kings, 4 queens, 4 jacks. And we're going to do, oops, sorry, I'm going to use my parentheses keys here. Just 12 out of 51 because you held that card out. So if I convert that to a fraction real quick, this is 40 out of 221. And you guys could see that decimal about 0.181 maybe if we did 3 decimal places. Just depends on how they ask you to do it in the question. All right, is anybody having a question about independent, dependent? All right, we're going to talk about kind of a special case here really quickly. So it says 2 events are considered mutually exclusive, is what we're going to write in here. 2 events, mutually exclusive if they cannot happen at the same time. Okay. Now, mutually exclusive, sometimes people will mix this up with independent. Independent events can happen at the same time. Like an independent event, like I could flip a coin and spin a spinner. Those are not mutually exclusive because they can happen at the same time, but they don't affect each other. So mutually exclusive is a little different. I just gave a couple examples. So if I'm rolling dice, you can't roll a 2 and a 3 at the same time. It would be one or the other. So that would be an option. That would be an example. Those are mutually exclusive. That can't happen at the same time. All these ones are mutually exclusive on this side. If you have to choose a dog and a cat, you can't choose a dog and a cat at the same time. They're different. They're different animals. You can't choose, if you're doing cards, you can't choose a heart and a diamond. They're both red cards, but they're not the same suit, so different at the same time. Can't happen at the same time. Now, I could, if I rolled a die, I could roll a 2 and I could roll an even number because a 2 is an even number. So those are not mutually exclusive. So I'm going to write over here. All these examples are not mutually exclusive. So I'm not going to use the formula I'm going to give you below here. I could, if I went to the dog store or whatever what is that place? Uncle Bill's. If I went there, I could choose a dog and a poodle at the same time because a poodle is a type of a dog. And I could choose a card that's a heart and an ace at the same time because they could be in the same suit. So those are not mutually exclusive. So these would not fall into the category that I'm going to use. So it just says, are mutually exclusive events the same as independent? No. The reason is independent can happen at the same time. Okay, now, if you have, in general, the probability of something or something else, I'm going to give you 2 different formulas. So if they can happen at the same time, in general, probability of A or B is going to be the probability of A plus the probability of B, and then minus, this is a little tricky, probability of A and B. Basically what would happen here, this would represent any kind of an overlap. Like we wouldn't want to count the probability twice. That'll make more sense, I think, in a second when we are going to work on these examples here. Now, if they're mutually exclusive, they can't happen at the same time. This is a little bit easier. It's just the probability of A plus the probability of B. So we just have to determine if there's an overlap basically when we do these questions. So can they happen at the same time or can they not? Okay, so it says about 30% of the United States population is under 20 years old. 17% of the population is over 60. What's the probability a person chosen at random is under 60 under 20 or over 60? Can I be younger than 20 and older than 60 at the same time? No. Okay, so these two guys are mutually exclusive. So that means we literally just add these probabilities together. Now, a probability, remember, can be between 0 and 1, or it can be between 0 and 100%. So both of these were given to you as a percentage. So literally you can actually just add the percentages together. So the probability that I'm under 20 is 30%, plus the probability I'm over 60 is 17%. So the probability you randomly selected somebody and they fell into one of those two categories would be 47%. Those are mutually exclusive. Okay, now a number cube, just dice. Just think of dice. So I'm going to write out these options here. This says probability of 3 or the probability that I'm odd. So probability that I'm 3 would literally just be 3. The probability that I'm odd would be a 1, 3, or 5. Okay, so these two things, 3 is an odd number, right? So these two things can happen at the same time. So not mutually exclusive. So here's how this would work. The probability I would get a 3 would be 1 out of 6. The probability that I would get an odd number would be 3 out of 6. But if you notice, what happens there, I count this 3 that's in both categories, I count that twice. So I have to subtract off the fact that I counted that twice. So I would subtract off 1 counted twice there. Now, if you don't want to use that little formula above, what I usually do is I write out my options and I just only do like, here's what, this is adding. I don't fail it like, okay, that's adding. I usually just don't do the overlap. I look at the options and I don't count it twice, so you can kind of skip that. But basically what would happen here, these would cancel each other out, and so it would be 3 over 6 or 50%. So I just don't, you can subtract off the overlap, or you could just ignore the overlap and just count all the different options here. So if I do the second one, probability I'm even. So if I'm even, 2, 4, or 6. All right, now the other option says less than 4. So less than 4, does that include 4 or not? No, if you're less than 4, that doesn't include 4. So 1, 2, or 3. Now here's what I would do. How many different numbers do I have there? I have 6 numbers written. How many different numbers are written though? Do you guys see how the 2's in both? So when I do these, I don't mess around with the overlap. I just don't count it twice. So I have 2, 4, 6, 1. I don't count the 2 again, and I have 3. So that way, these things can happen at the same, these are all not mutually exclusive here. So this should be 5 out of 6. Because you have 5 different numbers there. All right, now, I don't know if you guys remember this, but probability of odd, 1, 3, 5. Probability of prime. Prime means only the number and itself or its or a number and 1 or its multiples. So that would be 1, 2 is a prime number, 3 is a prime number, 5 is a prime number. Okay, how many different numbers do I have there? I have 1. We're just going to roll a die, so it only goes up to 6. Sorry, that's my fault. 7 is a prime number, though. It just wouldn't be on a die. Okay, so all I'm doing here, just how many different numbers are there? So I've got 3 here. The 2 is the only thing I add into the mix. So this should be 4 out of 6. If you want to use that formula, this would be 3 out of 6, bless you, plus 4 out of 6 minus the overlap, which the overlap, 1 is in both, 3 is in both, 5 is in both. So I would actually subtract off 3/6, and those cancel kind of like that first one. I just figure out how many are different, so that way, bless you. So this would reduce to 2/3. So you can figure out how many are different, or you can use that little formula, probability at A plus B, and then subtract off the difference. Okay, now I have 2 at the very bottom real quick because there's a question like this on the homework assignment. So it says A and B are independent events. If you have an and, anytime you see an and, you want to think multiply. All right, so probability of A and B, you literally just take the 2 probabilities, which would be 1/6 and 2/5, and you multiply them together. You do not need a common denominator there. This would be 2/30, which would be 1/15. So if you have an and statement, you're going to multiply them together. All right, now this says C and D are mutually exclusive. So if they are mutually exclusive, they can't happen at the same time. If you have or between 2 probabilities, you want to add those together. So if I have this situation, probability of C would be 1/2 plus the probability of D. Now, if you're adding fractions together, you do need a common denominator. So I just, real quick, I'm going to multiply top and bottom of that first fraction by 4. So I'd have 4/8 plus 3/8. So 7/8 would be the answer. I'm pretty sure this one on the homework assignment asks for it as a fraction because it gives you the probabilities as a fraction in the question. But you could easily change that to a decimal.